Alright, everybody, so same format as previous exams. Make sure that you know your N number, by the way. I had about 4 or 5 of you that didn't know your N number. If you don't know your N number, or if you bubbled incorrectly, your score is going to be delayed a day or two. So it's significant work for me to dig out who got their N number wrong. Just make sure you get your N number right and that you bubble it correctly. And note that on the form that it starts with 0, and it goes 0, 1 through 9. So sometimes students, bubble 3 and they're really bubbling 4 or whatever. There'll be 28 questions. I do have a freebie question, like you see on some of the exams. There's a freebie question, and I don't know. I stopped doing that, and then I say, well, let's start doing that again. So you're welcome. All right. There are 8 free response. As I told you, on the first page, it'll be split down the middle, and you'll have projectile motion. There's going to be a problem where you go up and come back down again, and then the other is going to be an inclined plane, where you have an inclined plane, you have a block on it, there's some tension, either pulling it up. There'll be a kinetic friction. There'll be both accelerating and non-accelerating parts to that question. Look at the Fall 19 exam. Those free response are very much like the Fall 19 free response. And as I said, there are other questions that are really similar to that. It's not that the Fall 19 exam was special, that I just, in that semester, started pulling questions out of the multiple choice and putting them in free response. So there are other questions that are really similar to those questions in past exams. Fall 18. Fall 20, we didn't do free response just because of, I forget. There was something going on that semester. Oh, it was the COVID business, right? So anyway, free response be like that. I just remind you on your free response, show your work. That I will, if you have work that appears to be on the right track, I will give you half credit for that. I mean, if you show me work that's just gobbledygook, no credit. But even if you get the answer wrong, you'll still get half credit if the work is, right. Okay, and then there are 20 multiple choice. I think it's about half between chapters 3 and 4, projectile motion and forces, Newton's laws. There are 1D problems, 2D problems. There are about 6 or 7 conceptual force problems, 5 or 6 conceptual projectile motion problems, and then there will be calculations for both 1D, 2D, and projectile motion. Okay? You want to do some, probably do you have specific questions, or do you want me, yeah, Claire? Fall 18, number 5. Oh, by the way, so as you're going through the exams, and when you encounter questions like this, or like this, remember that was on our exam 1, will not be on your exam. Fall 18, number 5. Okay, this is a good example. So remember, with projectile motion, you'll see several problems. You'll see one, this will be your free response, like that. You'll see a problem like this, where it's horizontal and it goes out like that. And then, hey, Diamond. And then you'll see another one where it goes up like this and then comes back down again. And this number 5 is like that number 3. Diamond, what's your last name? Sterling. Right. Okay, so I'm looking at this situation. You need to be familiar with all 3, because all 3 will be in there. Hey, Austin. Good to see you, man. All 3 will be on the exam. On this one, if the brick is in flight for 3 seconds, what I've just told you there is golden. That tells you that at this point, t is equal to 3 seconds. That means if I want to know the position at that point, then all I have to do is say y is equal to v0 y times t plus 1/2 ay t squared. And if I put in 3 seconds right here, then that means that I can calculate y. If I know the time, I just put it into that y equation, and it tells me that position at that time. That's why, for example, when we find t top, that's why that's so useful, because then we can figure out what is the position at t top. So I have v0 y, which is going to be 2.5 sine of the angle, which is 20 degrees, times t, which is 3 seconds, minus 5, that's half of negative 10. I'm using ay equals negative 10 times 3 squared. I do that, I get, make sure in your calculator that you're in degree mode. If you're getting wonky answers, you're probably in radian mode. I don't usually put those answers as multiple choices, like in the multiple choice. So if you're getting a wonky answer, just check your mode on your calculator. Also, I just want to be clear that, like, when you're doing something like this calculation, be careful that your 20 is in parentheses and that you're not really taking the sine of 60 degrees. Minus, what's 5 times 9? 45. I get minus 42. That means that from here down to here is 42 meters. Right, so the answer then is E. That's a good question. As I said, you're going to see all three types of projectile motion problems. Beginning and ending at the same position, horizontal, and then one like this too. Other specific questions? Yeah.
Acceleration, like where the matters with the positive and negative.
Oh yeah, let's look and see. Which usually is one where the acceleration is negative, right? Like that's. Okay, let's do this one. This is, gosh, do you remember? It's fall 17. Fall 17, number 25. There are actually two problems here. Pretty good indication of what your free response is going to be like. Except there will actually be 4 parts to your free response. And you know the way that works is I might ask you, what is the normal force? What is the frictional force? There'll be little questions. So there'll be things that you'll need to find along the way anyway. Here, first thing we're going to do is just draw all of our forces. There's our normal force. There's our weight. This angle is 30 degrees. That means that this angle is 60 degrees. I'm looking really to 26, where I do have a frictional force. I'm going to go ahead and put my frictional force here. We can solve 25 en route, but I'm just going to draw the frictional force for now. I think that's all that I have for this one. Now I'm going to redraw it over here. I'll try to give you plenty of space to draw it. So here's my normal force, Fn. This is Fw cosine of 60. And this is Fw sine of 60. And then this is Fk. Okay? Now in this problem, the very first one, Fk is 0. Okay? But on the next one, we'll have Fk be non-zero. So let's imagine that Fk is equal to 0 for number 25. And then if I want to find the acceleration, I say the sum of the forces in the x direction equals max. That's going to be negative Fw cosine of 60 equals the mass, which is 1 kilogram, times ax. And actually, Elena, you know, I don't know that, like, you probably would have gotten the right answer if you got the sign wrong. I'm sorry, this maybe is not the best example. But you always want to get your acceleration right. The reason that I know that that Fw is negative right there is because it's in the negative x direction, and this is positive x. Okay? We'll come back to that, okay? Huh? No. You mean a 2D problem, like an inclined plane with tension?
Yes.
Let's do this one, and then we'll look around at some other problems, okay? All right. So then I solve this. I get negative 10 cosine of 60 divided by 1 kilogram And that's equal to negative 5 meters per second squared. So that's 5 meters per second down the inclined plane. Okay? Then, if I want to add in friction, do that in blue. In number 26, it asks, what is the acceleration if I have friction? Now, first thing I need to do is figure out what is my frictional force. I know that Fk is equal to mu times the normal force. I know mu is 0.12, that's given in the problem, but I don't know the normal force. So now I need to figure out the normal force, but luckily, or not luckily, I have these forces in the y direction, so the sum of the forces in the y is going to be Fn minus Fw sine of 60. That's going to all equal to 0. So Fn then will equal to Fw sine of 60. That's 10 sine of 60. That's equal to 8.7. Okay? Now, I can figure out what is Fk. That's equal to 0.12. That's mu times 8.7. That's 1 Newton. So I have a 1 Newton frictional force. So looking back at my grid up here, I have this force is 1 Newton. So now if I do the sum of the forces in the x direction, that's going to be Fk minus Fw cosine 60 equals max. 1 Newton minus 5 newtons equals 1 kilogram times AX. So AX equals negative 4 meters per second squared. So D is the right answer here. Okay? Let's find another. That wasn't really what you were asking. Yeah. It's usually a problem where the acceleration is given, not one where you're looking for the acceleration. But this is a good example of your free response. Okay, your free response is going to be a lot like this. And just say, and along the way, those 4 questions, it'll probably be something like, what is the normal force? What is the frictional force? What is the acceleration here? What is the acceleration here without friction? It'll be sort of those types broken down as you work through the problem. Lance? No, I won't count off if you are, a little bit off with your sig figs. Now, don't keep, well, I'm not going to, nobody's ever wildly off with their sig figs. If you know what you're doing, you know what you're doing. Okay? Yeah, I got shoot, man.
Fall 2018, number 2 and number 3.
Okay, 2018. Okay, yeah, so this is a great example of what we're going to see on those first 4 questions on the exam. All right, so let's work through this. This is a problem where you have a projectile that begins and ends at the same position. So whenever I get to a problem, I always like to draw a picture. It just sort of helps me to think about what I'm doing here. And then I can remind myself that there are certain things that I know about the situation. I know that Vy equals 0. At the top, it goes up, stops, comes back down again. I know that Vx is a constant. It's equal to this value. Vy is big initially, and then it gets smaller as it goes up. I also go ahead and figure out what are my V0y and V0x. Even if I don't need them both, it's like I just have these first steps that I take on every problem. It's like this is what I'm going to do on every problem. And then once I find that you sort of get that momentum going, then everything else sort of begins to click. It's just, it's like something familiar that you can do. So V0y is 32 sine of 60. That's equal to 28. And v naught x is 32 cosine of 60. And that's equal to 16. These are both meters per second. What those are referring to, v naught y, v naught x. And remember, v naught x is the same throughout. So if I ever ask you, what is the x velocity at a certain time, it's always the initial x velocity. There's no acceleration in the x direction. Now, and that's what this question is asking. At the top of the trajectory, what is the speed of the ball? Okay, so this is actually a much easier problem than I was led to think at first. So the answer then is just going to be this number. 16, because at the top of the trajectory, that is my velocity. So a question like this, I know I said this would be like your free response, but in fact, this would be sort of something that you would have in the multiple choice part. Right, but let's go ahead and sort of work this out as if it were one of our free response, because I would ask you several other questions. Yeah, shoot, Tyler. Yeah, Vx is our initial velocity. Yeah, it's always our speed in the x direction. So that's why I have that cosine theta term. Remember your x and y components, okay? Your x component is your vector times cosine. Your y component is your vector times sine. That just comes from our trig functions, our definitions of cosine and sine. And then for the force problems, make sure you're always taking 90 minus the angle to get those vector components. All right? What did that say? The last thing I said? Yeah, on the inclined plane problems, make sure you're doing the complementary angle to find those x and y components. So on this problem, let's say that I wanted to know y, and I want to know x. To find y, I would say, well, I know that at the top, that vy, which is v naught y plus ayt, that's equal to 0. So I can say 0 equals 28 minus 10, that's ay, times t. So t is always going to be v naught y divided by 10, or 2.8 seconds. That's top. Then if I wanted to know y, I could just say, well, y at that time is v naught y, that's 28, times t, which is 2.8 seconds, v naught y times t, where t is the time at the top of the trajectory. And then that'll give me y at the top of the trajectory. Minus 5 times 2.8 squared. And then that is whatever it is. I don't know what that is. And then if I wanted to find x, I would say x is equal to v naught x, or just vx times t. Vx I found up here. It's equal, no, I'm sorry, not 28, 16 is equal to 16 meters per second times 2.8 seconds. Messed up, right? Not 2.8 seconds, but twice that. Because if I want to know x, I want to know the position over here. So I have to put in the time at that position, which is not 2.8, but 5.6 seconds. That's twice t top. So that is whatever it is. So on your projectile motion problem, I'd ask you y, x, almost certainly going to ask you that. I might also ask you what is the velocity at a particular time. So let's say, for example, what is the velocity at t equals 3 seconds, for example? There are 3 steps to that problem. First, recognize that Vx at 3 seconds is 16 meters per second. Sorry, Brian, that's the one that you did. Yeah, Vx is 16 meters per second, and Vy is V naught y, which was 28 times t, which is 3 seconds, minus 10 times t, which is 3. So that's 64 minus 30. That's 54 meters per second. Did I do that right? That doesn't look right. No, that's not right. Yes. I'm going too fast, aren't I? that t doesn't go there, right? So it's 28 minus 10 times 3. By the way, I could tell that that wasn't right, even without having, Jonas here to tell me, is that right? That doesn't look right. Because I got a positive velocity here when I know at 3 seconds that I have gone over the peak and am now coming down. So my Vy should be in the negative direction. It should better come out in a negative number because I've passed the halfway point and now the ball is coming back down again. So that gives me then 28 minus 30 or negative 2. And then the velocity is equal to the square root of 16 squared plus 2 squared. Technically, it's negative 2 squared, but I usually just leave those off because you're probably going to make a mistake in your calculator and do 16 squared minus 2 squared, but that's not right because it's a negative number squared, so your negative sign goes away. And now that's 16 point something. Okay? Oh, it's the Pythagorean theorem. That's where that comes from. So Vx is this vector. That's equal to 16. Vy is this vector. That's equal to negative 2. And then I want to know this vector right here. That's V. I'm not sure who asked that question. Elena, is that you? Oh, Faith, yeah. That's why you square it. It's the Pythagorean theorem. Okay? I know some of you are still struggling with those calculations. I understand that. But I also know some of you have been practicing this a lot. But as I said in class, you haven't really been looking at the conceptual questions. So I want to look at some of those, okay? Because I think often, really, there's just as many conceptual as there are calculations. And sometimes those are harder because you're thinking about these different situations. So let's look at some of those in projectile motion. Yeah, go ahead, Simon. I'm sorry, can you?
When it asks for the horizontal range, is that something that's for the y?
Just for the x and the y?
For number 30.
Number 30?
What is the horizontal range of the ball? So that would be the y?
No, the horizontal range is x. So that's what I did right here. This is the horizontal range. Yeah, good question. So, I don't usually talk in the question about variables, but I'll ask for it in words. So as you're going through, look for those key words that represent the different things that you're actually looking for, like horizontal range, vertical range, speed, yeah. So the speed, for example, is this part that I did, the speed at 3 seconds. Which isn't the x or the y component, it's the vector sum of the x and y components. It's not easy. That's why I tell you, this is the hardest exam. There's a lot that goes into this exam, even though really the equations are exactly what we used last chapter, that the problems are a lot more complex. Okay, let me look at number 7. So on these problems, you just go through and you ask yourself, is this a true statement? The initial horizontal component of the velocity is equal to the final horizontal component of the velocity. True. Because it stays constant. That's excellent, yeah. The acceleration is 0 at top of the soccer ball's trajectory. Watch it. Now the velocity is 0. The velocity in the y direction is 0, but the acceleration in the x direction is negative 10. So that's not correct. Now it is true to say that ax is equal to 0, but that's not what it's asking. It says that the acceleration, and the acceleration includes ax and ay. Words are important. Make sure you read every word and process what that means. Faith? It's constantly negative 10, right. Ay is always negative 10. The horizontal component of the velocity is maximum at the top of the soccer. No, the horizontal component is always the same. And the initial horizontal component is equal to the initial vertical component. It could be, but it's not necessarily true. So I would say also that statement is wrong. So it's going to be 1 only. Whew, those are tough, right? Because you have little words that if you're not reading them and processing them, then you're going to miss it. So Read through these very carefully. Practicing the old tests really help, but practicing the old test is also kind of a handicap because you'll be so familiar with questions that are similar that you'll get to one and then you'll skip over a word that's actually quite important. Not trying to trick you, that's not my goal, but I do need you to read every word carefully. Okay, you're in a plane and want to drop a relief package to people below. When do you release the package? We did a problem like this in the concept test. So here's your plane. Your package is right here. Your people are down here. As your plane is traveling along, you want to release it so that your plane and your package will be over at the same time because they'll both continue traveling with the same x velocity. So you want to release it before you get to the people. A cart is being pulled by a external force and accelerating. By the way, I just want to say that those concept tests are a great way to study for the conceptual part of the exam because sometimes I'll pull questions verbatim from those concept tests. Often I'll just pull questions that are similar. I might change them up a bit. But study those. Those are useful. They're on Moodle. The PowerPoints are on Moodle. You can also, if you have notes in the back of your book, you can look at those as well. If it's accelerating, that's the key word here. This cart is accelerating, and it fires a ball upwards, straight upwards. If it's traveling at a constant velocity, the ball and the cart will meet over here. But if it's not traveling, if the cart is accelerating, as soon as it shoots the ball will stop accelerating in the x direction. Because when the ball is on the cart, it's accelerating with the cart. As soon as it goes up and leaves the cart, it stops accelerating and begins to slow down in the x direction. While the cart continues going straight. So if it's accelerating, if the cart is accelerating, the projectile will look like this. So the cart will go in front of it. I did this in class where I threw it and I ran. Right, Kennedy? Was the plane accelerating? Well, in this one, the plane is traveling at a constant speed. I know it doesn't say that, but we're assuming that it is. I didn't really answer your question. No, if the plane's accelerating, you would still drop the package early before you get to the people. Because if you wait till you're over the people, I'm not sure if you've ever dropped relief packages. Probably not. If you wait till you get over the people, it'll just sort of keep going. The same is true for bombs. Have you ever dropped a bomb on somebody? No. Okay. Yeah, I think you're probably right. But that's good information to know if you're ever dropping relief packages or bombs. Johnson? Well, the conceptual questions. I think because people, so they're nervous about the math. Let's see if there's one there. Yeah, number 13 wasn't meant to be difficult. But we know that we have these two objects. Mass number 1 has a mass of 2 kilograms. Mass number 2 has a mass of 3 kilograms. I know that from their weights, right? Because those are their weights. And then their accelerations are going to be F over m, which is 20 divided by 2, which is 30 divided by 3. So they both have the same acceleration. But I should have known that because objects always accelerate at minus 10 meters per second squared when they're falling towards the Earth.
What if it was asking which one has a larger gravitational force?
Well, right, yeah, and I have asked that. So, like, I would instead give you the masses. One mass is 2 kilograms, one mass is 3 kilograms. The 3 kilogram mass would experience the larger force. which of course it needs the larger force to accelerate at the same rate. So I mean, okay. But I was, yeah, Claire, go ahead.
Know that there are 2 kilograms and 2 kilograms.
So FW equals mg. Got this question from a lot of people. So if my weight is 20 newtons, remember G is positive 10, not negative, positive 10. So M is 20 divided by 10, or 2 kilograms. I'm sorry, I know I sort of go through that quickly, because when I see a mass or a weight, it's like I always think, oh, well, that 20 newton object, that object that has a 20 newton force is really 2 kilograms.
So could you say that 1 kilogram is 10 newtons?
1 kilogram is 10 newtons, yes. A 1 kilogram object has a weight of 10 newtons. I'm trying to find your question. What was that? Oh yeah, you want to do one? Yeah, absolutely. Not like number 20, whatever that one I put the X through. Remember I told y'all in class today, not like that one. But there are other, I was looking for a 1D problem. I think that's what you're asking.
I think that's one on Fall 19.
Okay, this is fall 19, like number 15. I know this isn't a tension problem, but it's the same problem as if the object was like that. Those are the same problems, so you can treat them identically. But here, the normal force is up, the weight is down. If the acceleration is down, and I forget who asked, I think that was you, Elena, like the sign of the acceleration is really important here. So the forces is Fn minus Fw, that's equal to ma, but recognize that my a is negative. And so if my acceleration is negative, that means that I'm going to have my normal force. Sorry, she's trying to call me. My normal force is equal to Fw plus this negative ma. Remember, this is negative right here. So that means the normal force is going to be less than the weight, because I'm taking this amount away from that. It's going down, right? When you go down, you feel lighter, like you feel sort of, you have this, whoa, in a really fast elevator. So that means when you feel lighter, that means your normal force is less than the weight. If you feel heavier, if you're going up, that means that the acceleration was positive, and so the normal force is bigger than the weight, because the normal force is the weight plus this extra little amount. Huh? Right, or if you're traveling at a constant velocity, in that case the normal force is equal to the weight.
So when you're going down, the normal force is less?
Yeah. Mm-hmm. Like if you're on a scale or something, scales read normal force, they don't read weight. They really give the normal force. And the same will be true for tension. It's just, in tension, where you had normal force, it now becomes a tension. So same problem, it's just, is the force provided by a rope, or is the force provided by the surface, the contact force?
So if you were on a scale and an elevator going down, it would show you less weight.
Right. Mm-hmm. So if you're 180 pounds and you're going down, it's going to read 175. If you're going up, it's going to read 185. Okay? Particular questions?
Double the force, not just the acceleration.
Oh yeah, that's the one I was looking for, because students missed that. What? What? Oh no. So no, none like. I mean, you'll have vectors in the sense of, like in projectile motion and forces, but I'll show you what I'm talking about. Hold on, let me. This isn't what we were asking, Elena, but can we do this problem? Okay. If somebody knows where there's a problem like she's asking about, I'd love to know it. Kind of like the one we did in class today, right, Elena, with the two masses and what happens if you stick them together, right? So let's look at 19. I had X through this earlier because it was, I think we were preparing for the last exam when I did that. You apply a horizontal force to 100 newtons to a 25 kilogram mass, and it accelerates at a rate of 2 meters per second squared. Now, if I apply a 100 Newton force to a 25 kilogram mass, I would expect it to accelerate at 4 meters per second squared. Oh, this is, by the way, fall 20. Fall 20. So, what is the coefficient of kinetic friction? I would expect it to accelerate at 4 meters per second squared. 100 newtons divided by 25 kilograms, that's equal to 4. But it's going slower than that. That means there's another force. I have 100 newtons going in this direction. I have some kinetic frictional force going in this direction. And the acceleration is equal to 2 meters per second squared. So I'd say 100 minus Fk equals to the mass times 2 meters per second squared. Oh, I don't know Fk. I know the mass, awesome, yeah, so I can put 25 in there, and then I can solve for Fk. Fk is equal to 100 minus 50, or 50 newtons. So I have this 50 Newton force. But the question is actually asking for mu k. So to find mu k, that's equal to Fk, very good, divided by the normal force. That's going to be 50. Oh, but I don't know the normal force. But, what's that? You're talking to yourself, that's okay. This is a 25 kilogram mass on a horizontal surface with no other vertical forces. So I can say then that the normal force is equal to the weight. Because it's on a horizontal surface, I have a normal force, I have a weight, those two must be equal to one another. So 50 divided by 250, that's what, 1 over 5, or 0.2. That's a question that students sometimes miss. It's a little bit different than other problems that we've done.
And you know it's so quickly because you multiply it by 10, right?
Yeah, right. So the normal force is equal to the weight, and the weight is equal to m times g, and that's equal to the mass, which is 25 times 10, which is 250.
Even though it's accelerating, it's still equal to the weight.
Yeah. That's it. Yeah, because it's accelerating in the x direction, so the normal force is not affected by that acceleration. You're right, if it was accelerating in the y direction, the normal force would be different. That was the last problem we saw, right? These have x's in them, but of course they are relevant. What now? I mean, I wouldn't give you a problem where it's accelerating both in the x and y directions. That's what you're asking. Like if you had an elevator that's moving up and then you're pulling the object to the side. I mean, you could do it, but I wouldn't ask you to do that. Okay? I'd rather not spend time on that. That's okay. It's nothing different. It's just... No, I would. No, don't expect that. I don't see an example of that. Yeah.
Fall 2017 is kind of the same thing, but oh, I got it. 2014, number 18.
I hope that's 14. Oh yeah, here we go. Okay. So I push a mass with a certain force. I know F equals m times a. And I get an acceleration equal to 1 meter per second squared. So we'll call this m1. And my acceleration equals 1 meter per second squared. I push a mass with the same force. So these forces are the same. And my acceleration is equal to 3 meters per second squared. We'll call this m2. Is m2 bigger or smaller than m1? It's smaller. I know that because it accelerates at a bigger rate. In fact, m2 is going to equal to 1/3 of m1. Okay? It's smaller by a factor of 3 because F equals ma. I get 3 times the acceleration, so m2 is 1/3 the mass. Now, I have two masses. One is m1, and the other is 1/3 of m1. I stick them together. It has a mass of 1 plus 1/3. That's 4/3 of m1. And then I push on it with the same force, whereas before I got an acceleration of 1 meter per second squared. Now, F is equal to ma. I have 4/3 the original mass, so I'm going to have 3/4 the original acceleration, which is d. Students miss that question a lot, and you will see a question like that on the test. Something similar to that. Look back in the concept test. There are a couple of similar questions in the concept test, so review those. I think I did a question where I put the 4 stars on it. I think it was something similar to that. So yeah, students, that's a tough question, don't you think? Like, it's hard to follow. Even I have trouble. I've been doing this for 20 years, and I have trouble sort of thinking through all the relationships. But that's probably the most missed question on the test.
So if you find if you look at the acceleration, just like we just did, and we know that acceleration and mass are inversely proportional to each other.
Right. Let me step through it entirely again. Okay, I'll erase the slate, and I can see blank stares on your faces. So, bigger. Okay. So I know that F equals ma. I have two masses. One, I apply a force. I'm going to draw it big. The first mass, I apply a force, and I get 1 meter per second squared. The second mass, I apply the same force, and I get 3 meters per second squared. Now, because I get 3 times the acceleration, I know that that mass must be 1/3 of the original mass. So if this mass is mass m, this mass is 1/3 of m. Now I put those two masses together, and I apply the same force to both of them at once. So I have m, I have 1/3 of m, 1 plus 1/3, that's 3/3 plus 1/3. Combined, these are 4/3 m. Now, F equals ma. I now don't have m, I have 4/3 of m. Now I have the same force, so what is the acceleration? Well, I have to, whatever I do to this variable, sorry Brian, whatever I do to this variable, I have to do the opposite to this. So this is going to be 3/4 the original acceleration. The original acceleration was 1. 3/4 of 1 is 3/4. Was that a sigh? I know it's fractions, right? But you need to, especially pre-meds, Okay, y'all need to be able to work with numbers in your head. And this is a great example. They're not difficult numbers, but you need to be able to work with numbers in your head because you'll have, MCAT numbers, no calculators. I feel like Jerry Maguire. You lost me at hello.
It's like 1/1 plus.
Y'all don't know that movie, do you? You ever seen Jerry Maguire? Y'all seen Jerry Maguire? Are you serious? Huh? You seen what? Lizzie? Is that a movie? Yeah. It's an old movie? Wait. Oh, okay. Yeah, you lost me at 4/3 or 3/4. So you got this. I put these two masses together, and now I have 1m plus a third m is 4/3 m. 1 is 3/3 plus 1/3, that's 4/3 m. So here I'm changing my mass by 4/3. So I have to change my acceleration by the opposite of that, or the inverse of that, which is 3/4. I think Julie and then Elena.
So it's like the first, like M1, would that be 1 always? And then you would just add whatever the difference, or like whatever the second one is?
Yeah.
Kind of?
Yeah.
Okay, so the first one's 1. And then, like if the second one is, well in this case it's 1/3, but if it was 1/2, you would just add that half to that 1?
Right.
It's always 1?
Right.
Okay.
Well, yeah. Yes. M. It's 1 times M. Right. 1 times M. Right.
Right.
Lena?
We don't have to work because I know how to do it, but for 19, when I enter it, with the force of 100 newtons, would that be like on the x-axis?
Yeah, we didn't really talk about this in your class, but you can use pulleys to redirect forces. Well, like in lab, right? Like y'all did the inclined plane. That this force you can redraw as this. This is that force, 100 newtons. There are no pulleys like that on your exam, but yeah, if you encounter that somewhere else, that's true. Okay. Yeah. This is, 2014. I just have 2014 through 2020, but really, like when you're going through the exams, you can, oh shoot, I don't have, there we go. When you're going through the exams, I think all of these exams are good practice. Maybe if you get as far back as 08. Oh, that was exam 1, I'm sorry. Oh yeah, I don't even have the exams. Yeah, any of the exams are great for practice. This does have universal law of gravitation, that F equals G mn over r squared. And as I told you on class today, not on the exam. What? No. We'll see it again next semester when we do electric forces. It's very similar. Let's do number 19. We'll make this our last one. So I want to know, what is the acceleration? Oh, this is nice because look, no friction. I just have this force pulling it up. So I have my force right here is 100. I'm just taking that first step, right? No, not an FK. In fact, this is a frictionless. Well, it says the pulley is frictionless, but there's no friction mentioned in this problem. I have Fn, and I have Fw. Look, I'm going to go ahead and resolve my Fw into its components. Fw cosine of 60, and Fw sine of 60. That's right. Fk only if we mention friction. So here I want to know the acceleration. I'm assuming that this block is going to go up I don't know that actually right off, because the weight of the block might be more than the 100 newtons pulling up. So let's see. I just do the sum of the forces in the x direction. That's Fw cosine of 60 minus F equals MAX. That is 10 times 10, 100 newtons, cosine of 60 minus 100 equals M was 10, AX. Minus 100 equals 10AX. So it's negative 50 divided by 10 equals AX. So that is 5 meters per second squared up the inclined plane. The reason it's up is because this is my negative x direction, and it came out to be negative 5.
Okay, so if it was the x for Fy, what would be x for?
Well, there is no acceleration in the y direction because the object is not moving in this direction. So AY is always going to be equal to 0. Now, I mean, I could ask a couple of things. Like I could ask, what is the normal force equal to? Yeah, that's what I would ask. What is the normal force? I would say that Fn is equal to Fw sine of 60. Minus what? No, let me show you. So I do the sum of the forces in the y direction is Fn minus Fw sine of 60. Always 0 in the y direction. I see you, Kennedy. Give me just a second. And then Fn is equal to Fw sine 60, which is 86 newtons, or 87 newtons. Okay. Kennedy.
So when you're going up static friction, friction is always going to be in the same direction on the graph?
No, it's always going to be opposite the direction of motion. So like for example, on this question, the kinetic friction would be in that direction. If I knew that it was moving up the inclined plane. So I'd have to work the problem first to see what is it moving without the friction, and then realizing, okay, well now it's moving up the inclined plane, and then I would apply kinetic friction down the inclined plane. Now I wouldn't make you do that. That would be mean. Okay? Jonas, and then Claire. Okay, great. Diamond. Go ahead, Diamond. Go ahead. Go ahead, Diamond.
So when we're starting up with some of the forces, how exactly do we know how to set up whether it's this plus this or this minus this? Or how do we figure out the order in order in which they're calculated?
When you do your vectors, you basically follow down and across.
So down and then left to right.
Yeah. Yeah. Let me make sure I get in on this. You're telling them right. But this is my positive force, this is my negative force, so it's going to be Fw cosine 60 minus F. Yep. Yeah, so if I had extra forces out here, it would be minus F minus whatever it is out there, whatever that force is. I don't even know. I think it was Claire or something like Claire.
Yeah, I have just one question about number 4 on ball 18.
Okay. This will be our last question. Okay, if you have additional questions, just hang out afterwards. Okay.
So are we gonna have a question like something like that?
Probably. Yeah. We did this one or one similar to it, but I made it. So this rocket, have you ever fired a rocket at a helicopter? hits right here, and I know that right there that t is equal to 2 seconds. So there's two things you need to do. You need to find what is Vx. I know what Vx is. It's 45 meters per second. And then you also need to find Vy. And Vy is V naught y, which is 0, plus Ayt. So that's equal to 0. T is 2, so it's minus 20 meters per second. So now I have two vectors. One is 45, one is 20, and I want to know the resultant of those two. So I say the square root of 45 squared plus 20 squared, and that looks like probably 54 or 49. I'm not sure what it is, probably 54. Okay? What's it? Oh, yeah. Right, because after 2 seconds, right, that's when it hits the helicopter. What is its speed when it hits the helicopter? At t equal 2 seconds. Absolutely.
So when you're doing horizontal range, you use your Pythagorean theorem.
No, no. When I'm finding the horizontal range, that's when I'm doing this. That's right. Vxt. Okay? Alright. I'm sorry, I have an appointment at 3. Make sure, some of you came in late. I need to make sure that I get your